So a chi-squared test for independence and chi-square tests for homogeneity of proportions use these things called contingency tables. So a contingency table, really, you can just think of it as a table. So we're going to look at this chi-square test for independence right now. So it tests whether two variables are independent of each other. So I have a couple of assumptions that your samples are random and that the expected value for each of the cells, so expected value, don't worry, we'll go over how to get those. So the expected value for each cell has to be greater than or equal to 5. If it's not, right, so if you have one cell where your expected value is too small, then you'll need to collapse, right? Collapse some rows, collapse some columns, whatever you need to do. Okay, so the expected value, to calculate them longhand, it's the row total. So rows go across and column total up and down. So find the total of each of those, multiply them, and then divide by the grand total. Okay, so here are the two hypotheses. So this is going to be the same for all of our chi-square tests of independence. H naught, so our null hypothesis, the two variables are independent. And H1, the alternative hypothesis, is that the two variables are dependent. So it's a chi-square test, so chi-square distribution. One more time with the picture. Remember, it's based on degrees of freedom. So degrees of freedom for contingency tables, it's the number of rows minus 1 times the number of columns minus 1. And then the test value, we get it the same way. The formula is the same as the goodness of fit, which means we're going to sum up observed minus expected squared divided by expected. So sum up, subtract, square, divide, add. Okay, so here's a first example. Oh, and by the way, I'll do that once for you the long way, and then I'll show you how to use the matrices in your calculator to have it do it for us. So here we go. So from a survey, we have the following information about coffee place preferences. So these are the observed values. So I want to test the claim that the class, which class you're in, so either the group 98 and 99. So here's an example where I had to collapse groups together in order to get my expected values to be bigger than 5. Notice I still have an observed value that is not bigger than 5. That's okay, right? Observed, you get what you get, but your expected values have to be bigger than 5. Okay, so anyway, so 98, 99 are together, 146, 152 are together. Okay, and then the coffee places that I had to collapse into, so Automocha, Dutch Brothers, Starbucks, Cafe Mela, Apple Cup, so these guys all had to get clumped. And then for those people who only drink coffee at home or don't drink coffee, and I'm not sure about you guys are all down here on the bottom row. Okay, so first thing I need is some totals. I need to get my row totals and my column totals. So if you want to grab your calculator, you can watch my arithmetic. So I'm just going to add all of those together. Okay, so for these guys, can I do it here? Let's see, 10, 24. Oh, nice. 15 and 5 is 26. And if I add those together, that looks like 50. So I could verify here. I'll just check the last number. So that's 8, 9, 10. Okay, awesome. So the grand total is going to be 50. Okay, so now let's see how we would get our expected value. So I'll grab a blue color here so you can kind of see. So I'm going to do, so when I say row total, so to get the expected value here in that first cell, so I need its row total, 13, times its column total, 24. So 13 times 24, and then divided by 50. So 6.24. I think I'm going to keep all of those decimals. They're not that many. I'm kind of okay with that. And then, so now to get this next one, I take its row total times its column total divided by the grand total. So 13 times 26 divided by 50. By the way, right, if you add those two numbers together, you should get to your 13. Think about that degrees of freedom. So I could have gotten the same number by subtracting that total from the 16 or the 6.24 from 13 would have given me that same number. Oh, sorry. Okay. So go ahead and do all your expected values. I'm just going to kind of bust through. Okay, so I just totally cheated. Did you see what I did? So I did my first, so I'm on for the 7.2. I did 24 times 15 divided by 50. I got 7.2. Now, I know that those two had to add up to 15. So after my 7.2, I did minus 15. My calculator told me negative 7.8, but that's only because I subtracted in the wrong order. And I knew that it was going to be off by a negative sign, so I just wrote down the positive version. If you feel comfortable with that, it saves you just a few keystrokes. Okay, continuing on. And this one's the same. Okay, so now I have all of my expected values. I could get my test value. You know what? I'm really not going to do that in front of you. I'll write out a few of them. So my test value, my chi-square test value, 5. So observed, 5 minus expected squared divided by the expected plus. And then you do the next cell. Observed, oh, that's 8 minus expected squared, remember to square those, divided by expected, plus dot, 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 right? You have to do that for all 8 of the cells, right? And then your last one would be that 6, right? So this guy here would probably be the last one you get to. Observed minus expected squared divided by expected. Now that's a lot of keystrokes. So instead, what I'm going to have you do is I'm going to show you, and it's actually going to give us all of those expected values as well. I just wanted you to know where they come from. So we're going to go to your matrices. So the matrix, it's on the left-hand side, it's kind of just under the math button. It's the second feature of the x to the negative 1. Can you see that there? I know it's really hard to zoom in. So I'm going to go ahead and select that. And you'll see I have some matrices already. So the first thing that you'll notice there is that this 2 by 3 and 3 by 1, that's the size of a matrix. So we have to tell it the size. So we need to know what the size is. So the size of the matrix, it's the number of rows by the number of columns, right? So for this particular one, I have 1, 2, 3, 4 rows. Oh, hold on, I did that again. Okay, back to my matrices. So I'm going to go over to Edit, and we'll go ahead and put this in matrix A. So just hit Enter, and I want it to be a 4 by 2. Okay, so, and you'll notice, oh, I'm so sorry, 4 by 2. Let me do that again for you since that was off the screen. So matrix, Edit, Enter, and then 4 by 2. And once you do that, you should get something that looks like the same size that we just had. So we're going to go ahead and put in all of those observed values. So 5, and it's going across. So 4 by 2. There we go. 5, 8, 10, 5, 4, 6. Okay, so my observed matrix is in. Okay, I'm going to put my calculator away. I know I'm doing this kind of piecemeal. I apologize for that. Let's go ahead and get going on let's write our hypotheses, then I'll show you where the test is. So null hypothesis, class and coffee place are independent. So that means it doesn't matter which class you're in, the same proportion of you should like Automocha over Dutch Brothers. Okay. Or, right, for the alternative, class and coffee place are dependent. Okay, that's kind of it. Okay, back to the calculator. Okay, so I don't know if you saw when we do stat tests. So I'm down at the bottom. There was our chi-square goodness of fit. The next one up is just a chi-square test. That's what we want. And oh gosh, I hope it doesn't put this in the matrix. It didn't, yay. But look what it does. I have observed, and those square brackets, that's kind of an indicator for matrix. And it has the letter A already there, which is nice, because that's where I put my observed matrix. If you did the same thing I did, you're fine. If you have nothing in your expected, don't worry, it's going to put it in B. So you don't have to put anything there if yours is blank. And then down to calculate and enter. And there is our test value. So if we would have done all of this computation here on the screen, it would have told us that test value of 3.19. So that's our chi-square test value. Sweet. And I see the p-value there, and I know my calculator's on top of it. I'm just going to copy it down so I can move my calculator again. 0.363. And notice it has our degrees of freedom is 3. So let's go ahead and verify that using that formula I talked about. Okay, so degrees of freedom, number of, where is it up here? So number of rows minus 1. So I had 4 rows minus 1 times the number of columns, and I had 2 columns, minus 1. So 4 minus 1 is 3, times 2 minus 1 is 1. So yes, same. Okay, so now we're just going to make it all look pretty here. So our p-value is that 0.363, our test value 3.19, critical value, okay, we could go find it somewhere. Decision, that's a really big p-value, right? That's bigger than alpha, so we will not reject the null hypothesis. There's not enough evidence. Let's see, do we think what the claim? Are independent. So the claim will be the null hypothesis. So there's not enough evidence to, let me go ahead and pull this up again. Do not reject the null hypothesis. To reject the claim that class and coffee preference are independent. Okay, next one will go faster. There was a lot of exposition there on the first one. I'm going to use the matrices again. Here we go. Okay, so following table shows the frequency for successes and failures for different treatments of a stress fracture and a foot bone. Compute the, oh, I forgot to show you the critical value. Oh, okay, I'm sorry. One more time, sorry. Critical value for that one. So 3 degrees of freedom from the chi-square test. Alpha was 0.05. 3, there's that 7.815. Okay, so just in case you wanted to know what that was, I should have finished the problem. My test value is to the left, to the inside, leads to the same decision. Okay, sorry about that. I just realized I hadn't finished that off for you. Okay, here we go. So hypotheses, treatment, and success are independent. Okay, so what would that mean if they were independent? It would mean that surgery or non-weight-bearing cast for 6 weeks have the same probability of success. So if they have the same probability of success, probably you're not going to opt for surgery, right? If they're independent. So the alternative then would be that they are dependent. It matters which one you have on how well you do. Okay, so let's see, what's our matrix going to be? What's the size of our matrix? So rows, I have 4 rows again. Column, I have 2 columns. So I have a 4 by 2, matrix. Okay, somebody out there remind me to show you where to get your expected values when we finish these. I'm not going to actually write them in here. I'll try to remember to go look on my calculator. Alpha is 0.01. I'm going to just look on my chart over there. My degrees of freedom, those look like 3 again. So I actually remember from just that last time, 7.815. Okay, so let's go ahead and grab your calculator. Go to your matrix. So it's over here on the left, remember. First thing you need to do is edit. So A, mine's already set up for 4 by 2, so I'll just verify. And now I'm going to put in my observed value. So matrix A gets your observed. So 54, 12, and make sure it's going across. Okay. And once you have them all input, stat tests, and then it's down at the bottom. Observed, expected, and calculate. Okay. Hopefully you have the same things I do. So my p-value is 1.3. Look all the way over there to the right, times 10 to the negative 12. Oh my gosh, that is so small. We are going to heartily reject the null hypothesis before I forget. The test value, 58.4. So we're rejecting the null hypothesis. My test value way over here, rejecting the null treatment. And success are dependent. Okay, so it matters, right? You'll have a better chance of, you'll have a different chance of success depending on which treatment you opted for. So now I'm going to put my calculator back up one more time. We're technically done with the hypothesis test. So now I'm just going to show you where to find those expected values. And it might take me just a second. So I'm going to go back to my matrix. And I'm just going to go on B because that's where it was putting my expected values. And when I hit enter, it puts them here. And I know there's a way because well, it's okay, I guess. I can see them in there. So my expected values here, 47.5. Sometimes if I have too many columns, it goes off the screen because it gives me too many decimal places. And I know there is a way around that. And I think you go to the stat menu to look at the matrix to make that happen. But I can't remember for sure. So I just went down the first column and I rounded to tenths. And I'll do the same thing for my failure column. So 18.5, 25.8, 20.5, and 6.2. So this is what we would expect to have happen if the two things were independent. So you can kind of see where some of the differences are. All right, here's a big one and here's a big one. Right, the difference between the observed and what you would expect if they were independent. Okay,